Hey, what's up, guys? Coach Mims here. We're going to start talking about lesson 1 today, okay? Lesson 1 is shifting, reflecting, and stretching graphs of functions, all right? So if you look at A, we have a basic square root function, okay? Now, most of you might not remember what a square root function is, but we will talk about it, okay? Now, remember, f of x is our output, and then our function is the input, okay? So if we input something, we will automatically get an output, all right? So check this out. What's the square root of 0? It's 0, right? So when x is 0, y is 0, okay? Now, if x is 1, what's the square root of 1? 1. Well, what's the next perfect square that we have? 4, right? Well, what's the square root of 4? 2. Okay, now, as you could see, our function will look like this. All right, on part B, we're still dealing with a square root function, but as you can see, we're adding 2 on the outside, okay? So what does that mean when we add 2 to the outside, all right? Well, if x is 0, square root of 0 is 0. 0 plus 2 is 2. Square root of 1 is 1. 1 plus 2 is 3. Now, let's try 4. If x is 4, square root of 4 is 2. 2 plus 2 is 4. So when x is 4, y is 4. So now this is what our function looks like. Now, think about it. If we add 2 to the outside, what did it do to our graph? It shifted 2 units up. All right, part C. Now we're subtracting 2 on the outside. Now, you could kind of predict what's going to happen if in B we added 2 to the outside. It shifted up 2 units. So let's look what will happen if we subtract 2 on the outside, okay? Now, x is 0. Square root of 0 is 0. 0 minus 2 is negative 2, okay? So when x is 0, y is negative 2, okay? Square root of 1 is 1. 1 minus 2 is negative 1. So when x is 1, y is negative 1. Now, next perfect square, 4, right? Square root of 4 is 2. 2 minus 2 is 0. So when x is 4, y is 0. So as you can see, our function shifted 2 units down. All right, guys, let's look at part D. Okay, part D is a little different because now we are adding 2 on the inside. All right, so let's see what that's going to look like. So first thing I'm going to do is, go back to my pen here. I'm going to do x plus 2 and set it equal to 0, okay? Now, subtract 2 from both sides. X is negative 2. Why is x equal to negative 2? Well, that means that we're going to have to shift left 2 units, okay? So when x is negative 2, negative 2 plus 2 is 0. So square root of 0 is 0, all right? Now, when x is negative 1, negative 1 plus 2 is 1. Square root of 1, 1. Now, when x is 2, what happens? Well, if x is 2, 2 plus 2 is 4. The square root of 4 is 2. So now our function looks like this. All right, part E. Okay, so now we're subtracting 2 on the inside. So same thing we did in part D. I'm going to set x minus 2 equal to 0. Add 2 to both sides, so x is equal to 2. So, if we shifted 2 units left, in part E, we're going to shift 2 units right, okay? So, when x is 2, 2 minus 2 is 0, square root of 0 is 0. When x is 3, 3 minus 2 is 1, square root of 1 is 1. Now, when x is 6, 6 minus 2 is 4, square root of 4 is 2. So this is our function after we shift right 2 units. All right, guys, so now we're looking at part F, okay? So part F is very similar to what we did in part A, but as you notice here out front of the function, we have a negative sign, all right? So the negative sign that is outside of our function tells us that we are going to reflect over the x-axis, okay? We will still use the same x values, the inputs, but our outputs are going to be a little different now because they will be negative, all right? But, 0 is always going to be 0. The square root of 1 is 1, so negative 1. And then square root of 4 is 2. Well, still got the negative sign. So when x is 4, y is negative 2. So now our value looks like, or our function looks like that. Now, let's peek over to part A, and the only thing we did was we literally flipped it about the x-axis. Alright guys, part G. Multiply the outside by 2 and multiply x by negative 1. Alright, now right here, this 2 is what we call a dilation. Alright, now a dilation is kind of like we're basically having to multiply whatever our x value is, okay? So what that means is we're going to have a vertical dilation by a factor of 2, okay? And we're not done. Look inside the function. What else do we have? We also have a negative sign. Well, the negative sign is inside of the function, so here we will have a reflection over the y-axis, okay? Over the y-axis. Now, let's start doing our x values. Well, when x is 0, y is 0, okay? Nothing changes for us, all right? Now, when x is 1, what happens? Well, when x is 1, we have a negative inside the square root, so that's imaginary, okay? So we got to start thinking of how can we make that negative somehow disappear to where we could take the square root, okay? Well, let's try negative 1, because we know 2 negatives make a what? A positive, okay? So negative 1 times 2, well, negative times negative 1 is positive 1. Take the square root of positive 1 is 1. 2 times 1, what do we get? It's 2. So when x is negative 1, y is 2, all right? Now let's look at negative 4. Well, everybody knows the square root of positive 4 is 2. So, and when you multiply it by 2, you get 4. So when x is negative 4, y is positive 4, okay? So our function now looks like this, okay? This is a little different from what we've seen before because now we have a vertical dilation, which is a factor of 2, and we have a reflection over the y-axis, as before we saw a reflection over the x-axis. All right, in part H we have a function, and here it is being multiplied by -1, and we're subtracting 2 on the inside, all right? Now, the subtraction is now coming from the inside of the function, okay? So now we have to think opposite, all right? So it's subtraction, right? Yes. So what we have to do is we have to set what is in the square root. We have to set it equal to 0, and then we just solve for x, okay? Add 2 to both sides, x is equal to 2. Well, just divide both sides by -1, and x is -2, okay? So when y is 0, x will be -2, all right? Now, here we got to think about perfect squares that will happen inside of this function. Now, you can make an xy table if you like, and let's say -2 is 0. You can make an xy table to try to find what those perfect squares will be, just so you're not having to use your calculator and estimate what that might be. All right, just for the sake of time, let's look when x is -3. Okay, when x is -3, well, we have a negative sign already, so that's +3 minus 2, which is 1, and the square root of 1 is 1. So when x is -3, y is +1. Okay, now let's look at when x is -6. Okay, let's see what happens. All right, so going back to my function, negative times -x is +x. 6 minus 2 is 4. Square root of 4 is 2. So when x is -6, y is +2. So -6, +2. All right. So with that being said, we had a reflection over the y-axis because the negative sign is where? Inside of the square root, okay? And we shifted 2 units to the left. All right, guys, same thing, and nothing really changes. It's very similar to the one in h, okay? We still have a negative sign that is under the square root or inside the square root, however you want to say it. And we have an addition now, so we're adding 2 on the inside. Well, let's do the same thing where we did in part h to begin with. We did -x plus 2 is equal to 0. So we're trying to figure out what happens when y is 0. So you subtract 2 from both sides, divide by -1, x is +2, okay? So 2 when y is 0. Now, what happens when x is 1? +1 here, okay? We're not talking negative. Well, -1 plus 2 is +1, and the square root of 1 is 1. So we can already tell that the negative sign means we're going to reflect over the y-axis. And you can see with the adding 2 on the inside of the function, we know that we're going to shift 2 units to the right. Okay. Now, we got to start thinking about perfect squares here. Okay, I know it's hard when we're just given a function off the top of our head, but we could always do our XY table, okay, if you want, and you don't feel comfortable doing quick math in your head. Excuse me. So what I'm going to use right here, all right, is I'm going to use -2, okay? So negative times -2 is +2, correct? Everybody agree with me? Right. Okay, y'all know that. So negative times -2 is +2. 2 plus 2 is 4. Square root of 4 is 2. So when x is -2, y is -2. All right. Now, let's look at this. What happens when x is, let me think, let's see. What happens when x is -7? Okay. Negative times -7 is +7. 7 plus 2 is what? 9, right? Well, we take the square root of 9 and we get 3. So when x is -7, y is 3. So our function will look like this. Excuse me about my drawing, guys. I'm not Picasso. All right, guys, moving on. I'm going to read the directions. Based on your observations, predict how each of the graphs of the functions below would be different from the graph of f of x, which is equal to the square root of x. State the changes that would be made to the basic graph. Now, we're going to talk about domain and range. So we're going to state the domain and range. Remember, domain, when we hear the word domain, we automatically want to think of the x values, okay? And then when we hear range, we automatically want to think of our y values, okay? So x domain, y range, okay? So now let's look at it. So we have g of x is equal to 2 times the square root of -x plus 1 minus 3, okay? So I'm going to look at the left side, and then I'm going to work my way in, all right? So first part, we have a vertical dilation of, or excuse me, not of, by a factor of 2, okay? Now, the second part, we have a negative sign, but pay close attention to where the negative sign lays, okay? It lays within or inside of the square root symbol. So we're going to reflect about or over the y-axis now, okay? So we have a vertical dilation by a factor of 2. We have a reflection over the y-axis. Now I'm going to start looking at my horizontal and vertical shift, all right? So part 3, I'm going to take what's inside of the square root and set it equal to 0, all right? Just figure out how many units we're shifting either left or right. So to solve, subtract 1 from both sides, x is equal to -1. Divide -1 by both sides, x is 1, all right? So we're shifting to the right 1 unit, okay? So shift 1 unit to the right, all right? Now, real quickly, if you look, outside of that function, we have a -3, okay? Outside of the square root, I mean. So we have a -3, which means we're going to shift 3 units down, all right? So let's go ahead and let's find our point that starts our graph, all right? So we are shifting 1 unit to the right and 3 units down. So right about here, okay? Now, let's see what happens when x is equal to 0. So when x is equal to 0, we have 2 times the square root of 0 plus 1 minus 3. Well, 0 plus 1 is 1. The square root of 1 is 1. 2 times 1 is 2 minus 3. So when x is 0, y is -1. See here, we had a vertical dilation of a factor by 2, okay? It's kind of like rise over run, if you remember that from Algebra 2, okay? Up 2 over 1, factor of 2. But why are we going to the left instead of the right? That is why, okay? That is why. Now, moving on to the next one. Let's see what happens when x is equal to -3. Well, we know -3 is, negative times -3 is +3. Plus 1 is 4, square root of 4 is 2. 2 times 2 is 4, 4 minus 3 is 1. Okay? So when x is negative 3, y is positive 1. Okay? Now, I know I'm going fast, but I'm doing these off the top of my head. You will have access to a calculator. So if you want to try different points, you are more than welcome of doing that. But I don't have a calculator app on here, so I'm just doing these off the top of my head. But you're more than welcome to do the XY table. Use your calculator for whatever you will need. All right. Now, I'm going to do one more point because I know there's another perfect square that is on this graph. So let's do negative 8. Okay. Negative times negative 8 is 8. 8 plus 1 is 9. Square root of 9 is 3. 2 times 3 is 6. Minus 3 is what? 3. So when x is negative 8, y is positive 3. All right. So now my function looks like this. Okay. All right. So now let's talk about domain and range. Okay. So domain is the x values. And range is the y values. All right. So the domain, we want to look where basically at our graph, but from here to here. All right. Well, our graph starts when x is negative 1, and it goes until negative infinity. All right. So we always read the graph from left to right. So we have an open bracket, okay, a negative infinity. The reason why it is open is because it is continuous. All right. Now it is from negative infinity to 1, positive 1. Now we have a bracket because our graph ends right here when x is equal to 1. All right. Now range. We go from negative 3 to infinity. If you keep going on and on and on and on forever, this graph will actually end up going to infinity. So we start with a bracket, and the first is negative 3, and then it ends with infinity. Okay, so we close that with a parentheses. So always use brackets when the graph is discrete, which means it's not continuous at that specific point. Okay, use the parentheses if the graph keeps going on and on and on to infinity. All right. All right, moving on to the next one. Here we have h of x. Okay, and like what we did before, I'm going to move. I'm going to work from the left side and move to the right. All right. Well, here we have a negative sign on the outside of our function. Okay. So what that means is we're going to reflect over the x-axis. Okay. Now I don't have a dilation or anything like that, so now I can start working inside the square root. So what I'm going to do is I'm going to set what's under the square root equal to 0. And then just solve. So here we have x is equal to 1. So that means we're going to shift right 1 unit. All right, we're going to shift right 1 unit. Now, the last part, we need to pay attention to this plus 3. All right, so 3 is being added to the outside of our square root. So what that means is we're going to shift up 3 units. All right. So now we can start doing our first point. So we're going to shift right 1 and go up 3. So 1, 3. So right about here. Okay. Now we're reflecting over our x-axis here. Okay. So pay close attention to this. So here you could do your XY table, whatever you want to do. You could do it on the top of your head, doesn't matter, who cares, whatever you want to do. All right, here for the sake of time, I'm going to do it off the top of my head. All right, so I'm going to look when x is equal to 2. So when x is equal to 2, 2 minus 1 is 1, the square root is 1. So we have negative 1 plus 3. So when x is 2, the square, or when x is 2, y is 2. Okay? Now, guys, don't freak out. I know I'm moving fast, but you will have a calculator handy. Okay? You do not have to do these on the top of your head. All right? You can take this video, you can rewind it, listen to it again if you have to, but just for the sake of time, and we still got a lot to cover, just rewind, listen to it a few times, and then you'll get it. All right, don't worry. All right, moving on. So I'm going to pick when x is equal to 5, okay? Because I know 5 minus 1 is 4, square root of 4 is 2, negative 2 plus 3 is 1. So when x is 5, y is 1 right here, okay? So our graph now looks like this, okay? We reflected over the x-axis, but if you look, our starting point is at 1, 3, okay? So our graph will eventually cross the x-axis, but in this sketch, it actually does not, okay? So let's now move on to the domain and range. So I'm going to look at the domain and range. All right, so the domain the domain is what value? It's our x values, right? Yeah. So I'm going to start with my x values, okay? And our graph starts when x is 1, okay? So we have a bracket 1. Now, this arrow right here tells me that we're going to keep going on and on and on and on to infinity, okay? So we have positive infinity with a parentheses, okay? Parentheses mean that it's not continuous. It is, in fact, discrete. So that is our domain. Now let's look at our range, okay? Now, this is very, very important. If you look at the arrow, I know my graph's not perfect, but what it means is that this graph is going to keep going on and on and on and on and on and on till y is negative infinity, okay? And then the top of our graph, if we look at the y values, will be positive 3, okay? So negative infinity to positive 3. Now, quick question. Bracket or parentheses? Bracket, right? Because it stops at a whole number. All right, next section here. I'm going to read the directions for us. It says, complete the table below based on the observations that you have seen in the previous examples, okay? So here we have the equations with transformations. We are going to describe the shifts and or reflections that the graph of f of x undergoes. And then we're going to describe what would be done to the x and or y values to the graph of f of x. So basically, we're going to write it as an ordered pair, okay? Everybody knows that the ordered pair is x and y, okay? So here we have c, which is our constant, being added to the outside of the function. So we're going to shift up c units, okay? And as an ordered pair, that would be x plus y plus c, okay? So c is the constant that we are actually shifting up, all right? Now, moving on to the next one. Now we're subtracting. So now we're going to shift down c units, okay? Now, same thing as one before. We still have x, but now we have y minus c, all right? Moving on, we have plus c in the inside of our function. So we're going to do x minus c, set it equal to 0. Well, x is equal to negative c. So we're going to shift left c units. So our xy coordinates is x minus c and y. Okay? Now, same thing, x minus c, or excuse me, I messed up. The first one was x plus c. You subtract c from both sides. Sorry. I wrote that down wrong. All right, but now, x minus c is equal to 0. Solve for x. X is c. So we're going to shift right c units. Okay, So now we have x plus c y. All right. Now, negative sign is in front of our function, so it's going to reflect over x-axis. So we have x minus y, or excuse me, negative y, okay? And now we have negative sign inside of the function, so we're going to reflect over y-axis. And vice versa, negative x, y, okay? Now, absolute value. Absolute value. How many of you guys have seen that in Algebra 2? Okay, so when we have absolute values, I know we haven't done an example like this before, but we're going to reflect any portion of f of x below x-axis above the x-axis. So basically what that's saying is we will not have any negative y values, okay? And we'll look more into that into this unit. But what that means is x absolute value y, okay? So our y values will always be positive. All right, so we have y is equal to a times f of x. Well, we've already talked about that. We have a vertical dilation by a factor of a, okay? So vertical, we're going to look at our y values, so y times a, okay? All right, so now we're going to start looking at some functions that you saw in Algebra 2 in previous courses, okay? So in Algebra 2, you learn how to graph several other functions, graph the basic functions mentioned before. All right, so here we're going to look at the basic quadratic function, okay, f of x is equal to x squared. Well, same thing, if you don't know, you could do your xy table, but when x is 0, 0 squared is 0. Nope, grab my pen. When x is 0, y is 0. When x is 1, y is 1, because 1 squared is 1. When x is 2, y is 4. So 1, 2, 3, 4, and then so on and so on. Now, the good thing is, with this one, when x is negative 1, it is still positive 1. And then when x is negative 2, y is still positive 4, okay? Because we know two negatives make a positive. So our quadratic functions are going to look like this, okay? Kind of like a U, horseshoe, whatever you want to call it, okay? So x squared. Now, notice we do not have any negative values of y, okay? The only time we will have any negative values of y is if we have a negative sign, if we're shifting down or anything like that, okay? Now, let's look at part 2. Here we have absolute value functions, okay? Now, absolute value function turns any negative positive, okay? So when x is 0, y is 0. When x is 1, y is 1. X is 2, y is 2. When x is 3, y is 3. Now, when x is negative 1, the absolute value negative 1 is positive 1. When x is negative 2, the absolute value negative 2 is 2. And then when x is negative 3, the absolute value is negative 3. Okay? So our absolute value function looks like this. So kind of like a V, all right? As a quadratic function look like a U. Now later on into this unit, we'll kind of dissect absolute value functions a little more, but it's actually what we like to consider a piecewise function, okay? All right, so now we're going to look at the basic cube root function. We have f of x is equal to the cube root of x, okay? When x is 0, y is 0. Oh, get my marker. X is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is negative 1, okay? Now, a cube root. On this graph, we don't have 1 for the x value, so we're going to extend it one more. All right, let's say x is 8. Well, the cube root of positive 8 is 2. And the cube root of negative 8 is negative 2. So our graph, oh, excuse me, try to close this a little bit. So we have our function now looks like this, okay? All right, moving on to the next one, x cubed, okay? Kind of same thing we're going to do here, still focus on the same x values. When x is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is negative 1, okay? And when x is 2, y will be 8. And then when x is negative 2, y is negative 8. When x is negative 2, y is negative 8. So you're saying, Coach Mims, why do you keep saying 8? So we know 2 squared, okay, is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 cubed is, in fact, 8. All right, here we're going to describe how the graphs of each of the following functions will be different from the basic functions and graph the given functions. Okay, so we have g of x is equal to x plus 2 in parentheses squared minus 3. Okay, so work left from right. Okay, so I'm going to do x plus 2, set it equal to 0, and x is negative 2. Okay, so we're going to shift left 2. Okay, now here we have minus 3. So that means we're going to shift down 3. Okay. Now, if you guys remember, kind of like the standard form of quadratics is x plus h squared, or excuse me, x minus h plus 3. Okay. X minus h squared plus, excuse me, 3 is k. Okay. H being the vertical shift, and k is, or h is horizontal shift, k is the vertical shift. Okay, so we're going to shift left 2 and down 3. So 1, 2, 3. So this is now our vertex. All right, so when x is negative 1, negative 1 plus 2 is 1, 1 squared is 1, 1 minus 3 is negative 2. So when x is 1, when x is negative 1, y is negative 2. Okay. When x is negative 3, negative 3 plus 2 is negative 1, negative 1 squared, so negative 2. Okay. Now, for the sake of this purpose, I'm going to do when x is equal to 1 and when x is equal to, or when x is 0 and when x is negative 4. So when x is 0, okay, when x is 0, 0 plus 2 squared, 4, 4 minus 3 is 1. And when x is negative 4, negative 4 plus 2 is 2, 4 minus 3 is 1. Okay, so our function will now look like this. All right, now units with our x values are going to change a little bit, but really the only thing we want to pay attention to is our vertex. Okay, negative 2 and 3. Well, treat this as an invisible 1. Okay, so talking about rise over run here. So we're going to go up 1 over 1. Okay, and since it's quadratic, we have to take into consideration that it can be negative as well. So we got to go up 1 and then to the left 1. Okay, that's why we have our U shape. All right, here we have an absolute value function. We have a negative sign out front, and then we have x plus 1 inside the absolute value functions, and then we're adding 4. All right, so let's get started. So first, I'm going to work from the left to the right. We're going to reflect over x-axis because the negative sign is outside of the absolute value functions, okay? And then let's see where we want to shift. We're going to shift, set it equal to 0, solve for x, x is negative 1, so we're going to shift 1 unit left, And then the last part, we have plus 4 on the outside of the function, so we're going to shift up 4. Okay, so 1 unit to the left, up 4. 1, 2, 3, 4. Now, we have a v function, okay, or the function is going to be a v graph. Well, it's a negative, so we're going to reflect it by the x-axis. So our graph is going to look like this. Now you can pick your x values and figure out what y is. For example, if x is 0, 0 plus 1 is 1 plus negative 1 plus 4 is 3. So here's that. When x is 1, 1 plus 1 is 2, negative 2 plus 4 is 2, and then vice versa. If you were to do negative 2, negative 2 plus 1 is 1, negative 3, so x would be 3. And then when x is negative 3, we have negative 3 plus 1 is negative 2, 2 absolute value, negative 2, negative 2 plus 4 is 2. Okay, so that is what it'll look like. All right, guys, here we have a cube root function. All right, we have the cube root of negative x plus 2 minus 3. Okay, now I'm still going to work left to right. So looking at the inside, we have a negative sign, and that means we're going to reflect over the y-axis. Okay, and then the second part, we want to find the horizontal shift, so we take what's inside the square root, set it equal to 0, and then just solve. So x is 2, which means we'll shift right 2. And then last part, we have this minus 3, so that means we're going to shift down 3 units. Okay, we're going to shift down 3 units. So let's begin with our graph. So we're going to shift right 2 down 3. So right here. All right. Now let's see what happens when x is equal to 1. When x is equal to 1, we have negative 1 plus 2 is 1, cube root's 1 minus 3, so negative 2. Remember, you could always do your x, y tables. And then when x is 3, we have negative 1 minus 3, which is negative 4. Okay. Now, just for the sake of the graph, I'm going to show you what happens when x is equal to negative 6. So when x is negative 6, we have 6 plus 2 is 8, which is the cube root of 8 is 2. 2 minus 3 is negative 1. So when x is 6, y is negative 1. So now our function looks like this. All right, so here in this one, we have p of x is equal to x plus 4 cubed plus 1, okay? So our exponent is negative, so our end behaviors will be different, okay? Which means our arrows on our graph will be pointing in the opposite direction, all right? So starting with the negative sign, okay, it is inside of the parentheses, so that means we're going to reflect over the y-axis, okay? And then now we're going to look at the horizontal shift. So we have negative x plus 4 is equal to 0. Solve for x. So that means we're going to shift right 4. And then the last part, we have plus 1, so we're going to shift up 1, okay? So over 4, 1, 2, 3, 4, up 1, all right? Now let's see what happens when x is equal to 5, okay? Negative 5 plus 4, negative 1 cubed, negative 1 plus 1 is 0, all right? Now let's do when x is 3. Well, still 1 plus 4, or it'll be negative 3 plus 4 is 1, 1 cubed is 1, 1 plus 1 is 2. Okay, so now our function looks like this. with our end behaviors going in the opposite direction, okay? All right, here we have a table, and we're given the x values as well as our y values, and it says the table below shows ordered pairs on the graph of a function f of x that consists of line segments connecting the points in the table. Use the table to create a table values for each function below that is a transformation of graph f of x, okay? So like I said, here's our x values, here's our y values. Now, in number one, we have g of x is equal to negative f of x plus 2. So we're going to state the shifts and reflections that f of x undergoes to obtain the graph of g of x, stating what changes are made to which coordinates of f of x to obtain the coordinates points for g of x, okay? Now, first thing I'm going to do is I'm going to figure out what is happening in g of x, okay? So we have a negative sign that is outside the function, so that means we're going to have a reflection over the x-axis, okay? And then we're adding 2 to the outside, so we are going to shift up 2. So our xy coordinates will be x, negative y, because of reflection over the x-axis, plus 2, okay? Now, the x coordinates, looking at this right here, okay, well, it's still the same for g of x. So all of our x coordinates will be negative 3, negative 1, 1, 3, 5, okay? So nothing changes for our x values. Now, our y values are now, will become negative, and then we will add 2. So we have negative 5 plus 2, and that is equal to 3, negative 3, okay? Negative 3. In the second part, we have negative 1 plus 2, okay? Y now becomes negative, add 2, so y is 1, okay? Now, negative times negative 4 is 4 plus 2, okay? 4 plus 2 is 6, all right? Y is positive 1, so that is negative 1 plus 2. Negative 1 plus 2 is 1. And then last one for the y values, we have negative 2, adding 2 to it, and we get 0, okay? So now we have found the ordered pairs for what the g of x function, okay? So we could write them as negative 3, negative 3, negative 1, 1, 1, 6, 3, 1, and 5, 0. All right, now looking at h of x, we have we have h of x is equal to 3 times the function of x plus 2 minus 3, okay? So first thing I'm going to do, I'm going to work left to right to see what we have going on. So we have a vertical dilation of 3, okay? That constant, or that lead coefficient is 3, so that means we have a vertical dilation of 3, which means we're going to multiply our y values by 3, and you'll see that here in just a second. All right, part 2, now we're going to work on the inside. We have x plus 2 is equal to 0. Solve for x is negative 2, so we have to shift left 2, and then last one we have a minus 3, so we're going to shift down 3, okay? Now, let's see what happens when we set up our ordered pairs and what it'll look like and what we are going to do with these ordered pairs. So for x, okay, here we're going to shift left 2, okay? So we're going to take x, and then we're going to subtract it by 2, okay? Now, 2 parts for y. Well, here we have a vertical dilation of 3. So that means we're going to multiply the y values by 3. Now, we're not done, okay? We still have to shift down 3 units. So it is 3y minus 3, okay? So that is how we are going to find the ordered pairs of h of x from f of x, okay? So let's get started on x coordinates. So we're going to subtract 2, so we have negative 3 minus 2, and you get negative 5. Moving on to the y coordinates, so let's start with, we have 3 times 5 minus 3, okay? 15 minus 3 is 12, right? 3 times 5 is 15, minus 3 is 12. So our order pairs is -5, +12, okay? Now, moving on to the next one. X value, -1 minus 2. -1 minus 2 is -3. Y value, okay, we have 1 times, we multiply it by 3. Our Y value is 1. Subtract 3. So 3 minus 3 is 0. So -3, 0. Okay? All right, moving on. X value is 1. Subtract 2. X is -1. Look at our Y's. 3 times -4 minus 3. Okay, we have -12 minus 3, which is -15. So we have -1, -15. All right. Excuse me 1 second. I'm going to take a drink. All right. So now our X values, or our X value is 3. So we have 3 minus 2, and that is 1. And then our Y value is 3 times 1 minus 3, okay? And then 3 minus 3 is 0. So my order pair is 1, 0, okay? All right, last one that's on this one. Let's see, our X value is 5, so 5 minus 2 is 3. And then Y value 3 times 2 minus 3, 6 minus 3 is 3. So our order pair is 3, 3, okay? All right, moving on. Okay, same thing that we've been doing on the 2 previous examples. We're just going to keep rolling into this one, all right? First thing we're going to identify, is we have a negative sign inside of the function. So we're going to reflect over the y-axis, okay? And then for 2, we're going to now move to the inside of the function. Set -x plus 3 equal to 0. Solve for x. X is 3, so we're going to shift right 3, okay? And then last part, we're subtracting 2 from on the outside, so we're going to shift down 2, okay? So let's look at our order pairs. So we have reflection of the y-axis, so that means our x is going to be negative. We're shifting right, so we have to add 3, okay? And that will take care of our x. And now we have, for our y, we just have y minus 2 because we're shifting down 2 units, okay? All right, now let's move on to the table. We have our coordinates. First coordinate is -3, +5. All right, that x becomes positive, and then you just add 3 to it. Negative times -3 is +3. 3 plus 3 is 6. And then y is 5 minus 2, which is 3. So our order pair is 6, 3, okay? All right, moving on. Negative times -1 plus 3. Negative times -1 is 1 plus 3 is 4. And then we have 1 minus 2 is equal to -1. So our order pair is 4, -1. X value, so here we have a -1 plus 3, okay? -1 plus 3 is +2. And then we have -4 minus 2, which is -6, okay? Always remember your rules with negatives, okay? 2 more. X is -3 plus 3, so that is 0. And then 1 minus 2 is -1, so 0, 1. -1, excuse me. And then the last one, we have negative times +5 plus 3. -5 plus 3 is -2. And then 2 minus 2 is 0. And so our order pair is 2, 0. All right. I'm going to make a quick statement right here before we move on. These order pairs over here, if we were to graph these on the XY coordinate and then connect the dots, we would be able to see what this function right here looks like, okay? All right, guys, here we have piecewise functions, okay? Piecewise functions are going to be a little bit different than what you've seen before. In my opinion, they're a little bit more difficult than any other functions because you are having to graph two different functions over an interval. Okay, so we'll start here. All right, so I'm going to look at this first function right here, x squared, or x minus 2 squared minus 3. Okay, so I'm going to I already made an XY table, so I already know what my X and Y values will be. Okay, but if you look, we have -1 is less than X. Okay, so what that means is when X is -1, our Y value at that specific point will be a whole. Okay, so when X is -1, Y is 6. Okay, so here we have a whole. Okay. The reason we have a whole is because X is not less than or equal to. It has to be less than -1, okay? So that is why there's a whole, okay, all right? Now, when X is 0, Y is 1. When X is 1, Y is -2. When X is 2, Y is -3. And then when X is 3, Y is -2. And then when X is 4, Y is -2 as well. Okay, so what's going to happen is our graph is going to look like this. Okay, but we're not done. Okay, this is a piecewise function, so now we have to move on to when X is greater than 4. All right, so moving on to the next one. All right, we have X is greater than 4. Okay, X is greater than 4. So at 4, we're going to have a whole. So when X is 4, Y is 4.7 repeating, which is approximately or close to 5. So we're going to put our whole right about here. Okay, so our whole is right there. Now, when X is 6, Y is 6. And then when X is 9, Y is 8. Okay. Now, if you look, we still have a whole right here. Okay, this is because X is greater than 4 and not greater than or equal to 4. So now let's start talking about our domain and range. Okay, now our domain, we're talking about our X values. Okay, so we start at -1. Well, since -1 is a whole, we will have a open parentheses, okay? And then we know if it's infinity, then it is also open parentheses. Now let's look at the range, specifically the Y values, okay? So here we have our lowest point at -3. So we have a bracket, -3, and the graph goes up to infinity. So we have bracket -3, infinity, close parentheses. All right, guys, last one for this lesson. Our first function, we have the absolute value of x plus 2, or excuse me, x plus 2 in the absolute value bars, and then we're adding 1 to the outside, okay? Now notice x is less than -1, okay? So we will have a whole right there when x is -1. So when x is -1, y is 2. So we have -1, 2. So we have a whole right here, all right? And then now we're going to look at the x values that are less than 1. So when x is -2, y is 1. When x is -3, y is 2. So if you look, our absolute value function will look like this. All right, so the left side will keep going on and on and on, but here we have a whole when x is -1, okay? Now let's look, we have 3 when x is -1. So when x is -1, y is 3. So here we just have a single point at negative 1, 3, okay? Now, moving on to the last equation, we have negative 1/2 x plus 5, all right? So when x is negative 1, there is a hole at 5.5. Now, it's a hole because we have x is greater than negative 1, okay? Not greater than or equal to, so there is a hole. Now, now for these we have, you could just plug in your x values or substitute your x values. And so when x is 0, y is 5. When x is 1, y is 4.5. When x is 2, y is 4. And then so on and so on, okay? It decreases by half. So our graph of that function will look like this, okay? So this is what our piecewise function will look like. And now we just need to state the domain and range. All right. Well, the domain and the range are infinity, okay? Here we see that the x values will cover negative infinity and positive infinity, and then our range will also cover positive infinity and negative infinity, okay? So we have negative infinity to infinity, negative infinity to infinity. All right, guys, so on number 3, we now have 3 functions. All right, we have the square root of negative x plus 3 when negative 4 is less than or equal to x and less than 0. All right, so when x is negative 4, we have negative times negative 4. Square root of 4 is 2. 2 plus 3 is 5. So negative 4, 5. So right here. Oop. Right here. All right. When x is negative 1, let's see what happens. So negative times negative 1 is positive 1. Square root of 1 plus 3 is 4. So when x is negative 1, y is 4. Okay. Now, where is our hole at? At 0, right? So when x is 0, y is 3. So we will have a hole right here. So our function looks like this. Now remember, we have a hole because there is no equal to sign. It is just x is less than 0. All right, the second one, we have 2 when x is equal to 0, so we will have a point right here. All right, so order pairs 0, 2. Okay, now looking at the third one, we have square root of x plus 3 when x is greater than 0. Okay, when x is greater than 0. So we will still have a hole when x is equal to 2, or 3, excuse me. But when x is 1, y will be 4. Because square root of 1 is 1, 1 plus 3 is 4. And then the square root, when x is 4, we have the square root of 4, which is 2 plus 3, so it's 5. So 4, 5. All right. So now our function looks like that. In the domain and range, okay. So the domain, all right, is negative 4 to positive infinity, okay? Domain is negative 4 to positive infinity. Now, our range is when y is equal to 2, because of this point right here. Then we have a hole at 3, and it goes on to infinity, all right? So that's what it'll look like. All right, moving on, here we have the square root of negative x minus 2 plus 2 when x is less than negative 2. Okay, so we're going to use negative 2 for x, and it will be our hole. Negative times negative 2 is positive 2. 2 minus 2 is 0. So when x is negative 2, y will be 2. So here is our hole right here. All right. When x is -3, negative times -3 is +3. 3 minus 2 is 1. Square root of 1 is 1. 1 plus 2 is 3. So when x is -3, y is +3. And then when x is -6, so we have negative times -6, which is +6, minus 2 is 4, square root of 4 is 2, 2 plus 2 is 4. So when x is -6, y is 4. Okay, so our graph will look like that. All right, now moving on to the next one. Now notice -2 is less than x and is less than 1. Okay, so we will still have a whole at -2 and 1. So when x is -2, -2 times -2 is 4. 4 minus 2 is 2, so that is why our whole is right here at 2. And then when x is -1, we have 2 minus 2, which is 0. When x is 0, we have -2. And then when x is 1, we have 2 minus 2, which is -4. So when x is 1, y is 4, but here we have a whole due to the fact of our less than sign up here. All right, so now we have negative times x minus 1 minus 4 when x is greater than 1. So when x is 1, 1 minus 1 is 0, 0 minus 4 is -4, so that's why we have a whole here. When x is 2, 2 minus 1 is 1, square root of 1 is 1, so we have -1 minus 5. So when x is when x is -2, y will be -5, okay? Y will be -5. -2 minus 1, or 2 minus 1 is 1. Take the square root of 1, 1 is 1, minus -1 minus 4, you get -5, all right? Now let's see what happens when x is equal to 5. X minus 1 is 4, square root of 4 is 2, -2 minus 4 is 6, so, or -6. When x is 4, y is -6. So now our function looks like that, all right? So now we're going to work on the domain and the range, okay? Now this is going to be different because now we have to focus on the wholes, okay? We have, in the domain, we have 3 different intervals, okay? So we have -infinity to -2, and we have -2 to 1, and we have 1 to infinity, okay? So this is our domain. And now let's look at our range, okay? We'll write this down here. So this is our range, okay? So our range for the first interval is what? 2 to infinity. Or excuse me, let's work left to right, okay? Well, not left to right, but from increasing to decreasing, okay? So looking at the right side, we have -infinity to -4 right here. And then we have -4, 2. So this interval right here. And then we have one more, 2 to infinity. So that is our domain and range for this piecewise function.